Hey, Shane. Got a drill downstairs, but I did bring the new chuck head for you to. But don't worry, I've already lost the capture bolt thread screwed in.
Because it's on it.
Well,
How do you check off?
that's where you.
I've done that before. I told you about this.
Oh yeah, it's all in the making. And it probably matters. As soon as you fix it, it'll probably break. Because I was using it as like torque beyond torque, and it was like losing the AC motor. It wasn't moving; it was just going like this, trying wholeheartedly. And if those bushings are just hanging out in the same place while they're trying to AC roll, you'll just destroy them. So you can get white smoke the first time, the second time you see gray smoke. So I'm all in there. But I'll bring it back.
Wait. You have a new check?
Yep.
Did you buy the real check?
Yeah,
You checked it?
I checked it. You're gonna be our audience. I'm so glad you're here. Because if you weren't, it would totally change the dynamic.
What? There's nobody here.
Hi. Hey, man. There, how are you?
We're good. You know the first rule of Damn Tuesdays, right? You gotta bring catering.
Oh,
No one's gonna want to listen unless we bring catering.
I thought the first rule of Tuesday was
That is the second rule of Tuesdays. But luckily this is gonna be internet publicated
Oh.
service merchandise product. You wanted to go second.
Yeah, actually, now that you mention it, I did. You knew, you're psychic.
What, did you want to go last?
Well, sure, of course I did. How do you know?
All right. We got a bunch of VHS dongles for you.
I don't even need a dongle.
All right, are you just piping right into the VGA?
I'm just piping in my
Are you
pipes.
freestyling? He was freestyling, so he doesn't even need a computer.
Yeah, actually, I am kind of freestyling. It's a freestyle.
No, it's all in the works.
Oh,
You know how heavy I am.
you're just already on to like the next step, the next.
Oh,
phase.
no, there's so much left to do.
Hey, Jacob, you talking to me? No. You're here to listen to talks? Oh, what? I've just never been able to make it, like, even since like last year, when it was like, gosh, this time is really good for everybody, it's like, it didn't get any better for me. But, you know, gotta do what you gotta do today, I thought, so.
Yeah.
That's cool, so.
It's good to make it to your own talk.
Oh, no, I'm going to take it down. Maybe this weekend.
Oh, I see, June 1st, kind of thing.
Yeah, almost ASAP. Almost as soon as possible.
Where to?
Where?
America.
America?
I'm just going to hobo around until I get
My American America.
some notoriety.
A class for America.
You're teaching, is your class, is that all that weird stuff that's up in the air, is that resolved?
It's tentatively scheduled to not be canceled, but who knows what all that means. We're going to put up flyers today again.
Are you at capacity, or are you at?
Half-mast.
Oh, no.
10 out of supposedly 15 is deadline, and we got 10 already.
I have material in my talk that may be relevant, hopefully help you with your ongoing experience with the thesis process. Did you defend already today? Yeah.
That was really good. That's a really good.
That's a really good discussion points on maybe revising my papers and stuff like that, presentation, doing more research and stuff like that. So, yeah, I'm just glad I felt like I was rushed, very rushed with the paper. And so I'm glad that in the course of the defense, I had a little bit of time to sort of like cultivate more research to contextualize the. But yeah,
We'll just take the visions now.
sorry. We got 2 hours of sleep.
Was that this morning? Did you already do yours, Sarah?
Oh, yes. I'm just polishing off the final draft of the thesis paper. I put in like 20 pictures and 20 figures, 20 hand-drawn figures. Now it's up to 52 pages with all that chattel.
44 pieces of video.
Well, I'm gonna try to numb your brain for 20 minutes with Technicolor. And the topic for today is fun things you can do with the laser cutter that sort of transcend planar design. And also optimize for just wasting less material maybe. And everything I'm going to show you is gone through a dilation algorithm so that the shape of it is heightened, so you kind of get kind of an animation feel of each one. This first one is just this little heightener scaffolds, and it's really wasting material to print perfect circles all the time when you can just cut a circle into 4 quadrants and then embed like 100 circles on one piece of material. And this is some of the laser cuts for Eve's marionette scaffolding. So it's kind of like a dual crucifix, so you could wobble the back legs and the front legs, and it was all on one spine that had 2 bolts in it. And these slider areas are so that 4 bolts, like this will be taken 90 degrees to the other one, and then 4 bolts will kind of keep it at 90 degrees or close to, and you can tighten them so that you can kind of move the backwards and forwards of the legs a little bit.
Could you send me this for eventually if you were comfortable me using it in a press packet?
Yeah, sure. Here's what the laser cut boards look like for one of my final MFA pieces. That's just a bunch of light boards, and each one of these holes is like 5 millimeters. I doubt it was exactly 5 millimeters, but I had to keep tuning the size of the hole to fit 5 millimeter LEDs. And with laser cutting, there's always a little burnout, so you never know if you have the exact right numbers. But this is algorithmically designed, just using pi and splitting it into 7 and then splitting it into 14 or so that this is like offshoot Supposedly it's a little bit mathematically perfect. It doesn't look it though. Here's a Max program I made to two like Van Allen belt simulators. There's these cool magnetic fields that come off of the Earth, and I just tried to translate it into a bunch of concentric rings. And this one was attempted to be a piece of jewelry, but it was just so fragmented and so many slices into the material that it just kind of self-immolated. Because if you heat something up too close to other stuff, then it just kind of mushes and ruins any kind of coherence. These are from Google SketchUp. These are all planar slices of a pretty trapezoidal Mobius strip. In Google SketchUp, you can make an object and then slice it into layers and then list them all out in Corel Draw so that you can just cut them all to pieces and then glue them or bolt them all together. But you got to get the dimensions right because it's really easy to accidentally scale something. So like if you had 100 slices and you wanted it to be like a square 7-inch area, then you got to divide 7 inches by 100 and then hopefully you have a material that's that thin. Otherwise you'll get something that's just like too tall, like an acorn. This ended up looking like an acorn. And here's some water wheels I got off of the Google 3D Warehouse. Just with the pictures on screen, you can make a 3D planar model of a water wheel. A lot of the time I spent effort making structures just to hold up things. So the whole purpose of this structure probably is just to suspend those holes up in the air a little bit so that you can have a kind of like an axle. And so these two pieces are just to reinforce through those slots, and then I think these two things go at a 90-degree angle, and then they're held together by the elbows, and then the lengthwise go across to reinforce 3D structurally. There was someone on Kickstarter that was saying that they're making Theo Jansen rhinoceroses, and they showed a little skewed model of their laser cut. And so I just took a picture of that and tried to unskew it and then create my own Theo Jansen model based on a picture of what they're trying to sell. It didn't work out too well, but it could work better if I was using kind of like thick cardstock or like cardboard that's not corrugated, because then you can get bendability out of it. You can't really bend cardboard with anything. Here's some stuff that's based on Theo Jansen's models. He's got ratios for all these pieces to make like these huge like arrays of crab walking legs, and they're all out of phase with each other, so they kind of complement each other as they walk. This is a kind of a dumbed down version that only uses 3 lengths, but Theo's design calls for 7 different lengths, which just like studied crabs to find out how to make it happen. Here's how to make elasticity or like a spring out of even MFD fiberboard. As long as there's enough of a dissipation of like tension along those serpent lines, then the top thing can be bounced down to the bottom thing. And this was done with like 1/8-inch proto board. And if it was done with aluminum, it'd work even better. But it's very fragile, very exhaustible. And you can just take this design and then double it up, cut and paste in the right way, and see if this design worked out any better. I never even printed this one. This is like a concentric ring for a binary encoder, or just like concentric taps on a slip ring, so you can take energy into a rotation. And if you notice that all these pins are kind of out, so it's like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So 12 nails are on springs, and they're embedded in this, and they're all on a different ring, so like 12 different rings. And the reason that they're in a 4-square was that if they're all on the original line by each other, for one thing, they'd probably be off-sided, the weight and the balance of the slip ring. And for another, sometimes just stacking kind of macroscopic objects next to each other is too much. And so oftentimes you can like have half your pins on one side and then offset the other half on the other side. And it goes 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So you can fit more objects in confined space. The torque forge piece, that was one of my MFA projects. It required like these tubes, and these were the the planes for those tubes. And so these planes had these struts so that you had a long cylinder where all these contact electric tabs could be embedded. So this took a lot of fine tuning. And those little notches are supposed to be registering points for the slide-in sticks. Here's the first attempt on making like a spring mechanism out of fiberboard. It didn't work at all. I was assuming, I mean, if it was the right elastic stuff, that it would bounce back to this, and then the ones on the left would ebb left, and the ones on the right would ebb right, and then those 2 points would slide to the middle. But yeah, after designing that, had to move on to a new idea with the Oxbow Lake mechanism. I designed these for really thick material, like 1-inch wood, because I wanted to make kind of like a monorail where I could just have like a rod, and then like these would be like the carriage sliders. But the laser cutter has a problem where if you work with thick material, by the time you get through the top, the laser kind of loses accuracy and you get a bevel. So it's hard to get a pure cylinder cut through thick material. I had to make my own calibration units because you never know what the computer says on screen. It might not be the same thing as what it outputs, especially with per material. Like if you laser cut plexiglass, you're probably going to melt away a millimeter of material, accidentally ruining your calibration. I was into industrial assembly tools, so I just making versions of their objects with kind of like inner areas so that like something could rotate. If you just assemble all of these on this plane, then ideally with one little crank you can get just different oscillations. In kinematics, there's all these methods using linkage systems so that you can get kind of complex or mimicry motions. Here's a simple one. You just put 2 bolts in there, and hopefully if that thing in the middle just stays perpendicular, it'll just slide the arms open and closed whenever that's actuated. But you really got to get your tension right. And ideally, like this middle thing would have an inner rut so that it never slid out of perfect alignment. There's another method where you can keep a pin in here, and then as you turn this, ideally the pin slowly moves in. It's like forced to stay in that gutter, and then as you rotate this pin, then it'll move in and out like that. But it's not infinite. Like once it gets to the middle, it'll crack, or it gets out and it'll be stuck. So you have to know your in stops. Otherwise, you use the machine beyond its ability. Here's other ideas for carriages, where you just have through these 2 pins, you have like 2 stainless steel rods, and then you have like an embedded little car that can move up and down the carriage, and then the bottom one is for like a long piece of all thread, and then there might be a couple screws embedded in this that will let it be so that when you turn the all thread, then the carriage just slowly winds back to the left or to the right, just like our milling vise. Other methods, arms and linkages.
Are these your actual vector drawings then?
Yep, just Photoshop renders. Yep, so whenever you see a notch, you know it's a connector to take it out to like a 90-degree plane. Those little crossbars are notch mechanisms that let you steel bolt in, and then the nut fastens the 90-degree angle. Here's some more carriages, and you'll notice that this is it's like a rack and pinion, so that one gear rolls from there to there, and that's the extent of its mobility. And then motors would be suspended inside of those concentric rings. And using those bolt tabs, you can then suspend other things on that platform. Here's the vectors for the daxophones that I was printing last year on wood. It'd be 7 millimeters thick and then maybe like a foot long. And you could play them with a violin bow. And depending on the size of the voice hole, then you get different harmonics, different overtones, different kind of utteral, guttural speech sounds. This is a daxo, which is all of these are kind of like musical or exponential divisions for tones. So ideally, like the pitch, if it's on this fret or this fret, whichever one is suspended, it changes the pitch note by note. Just like how longer strings have to get like algorithmically longer or logarithmically longer for the notes to sound like equal distance. And then those are two finger holes. And this was printed on like, I had to print it on two, maybe like 3/4 inch pieces and then glue them together for the laser cutter to do any service. And after a while, it just proved irrelevant and I just laser cut the etch really quick on the wood and then took it to the bandsaw. Here's my spatial models. You could just make a castable core and then pour wax into them and then take them all out. So this is like 3 layers of like a 16-layer piece and then you just pour wax into it and then take out all of these little chips. And they have to be, this one's cut into 4 because there's so much undercut that there's no way to get these parts out. So they were rendered in 3D Google SketchUp and then sliced, and then I had to take each picture and then further extract it, or just put lines on it so that it was extractable from the object once it was created. Some more of those different objects. And then these are the registration pins for long all thread or welding wrong. It's just like a jigsaw puzzle though, because if you lose 1 or 2 pieces, it just kind of ruins the whole design. I'd optimize putting washers inside of all the negative spaces because I'm just going to throw away the material anyway. And I was putting these on exotic woods at first, put $100 into buying weird stuff from Africa that was just had a hardness factor. That way the sounds were more contained, like pine wood just wouldn't ever resonate. It's just kind of foam compared to hard lignum woods.
Did you try with other materials besides woods, or?
Nah, I never really wanted to do it with plexiglass. It just seemed too synthetic. But that would be the tonic. Find out what it does to a non-material kind of. This is completely aesthetic, but it's half the fun. This is a long chamber core print of 2 chain links that are embedded in each other. So to cast this, you'd have a casting hole on top, which would cast that independently, and then turn that over and cast the other one, and then hopefully take everything out. And then you have 2 chain links that were embedded in each other, made out of wax or resin. So it's going to new places that casting usually can't go, or just seeing what digital processes can offer casting. There's a sine wave print for one of my meat machines, one of the original songs I thought I was going to have the iPads play. And so all the negative spaces would be node-ons, and then these long streaks would be kind of gestures. And this is just a max patch that made just like 7 sine waves, but it omitted probably like the other 5 that are part of the series that would make it just like a pure lace everywhere. Here's some different variables for the same program. You can't see the inside of these cast cores, but this is a star tetrahedron. And this one was done, most of the other ones were done in squares, but this one was done in triangles so that it split off into 3s. These were the casting layers that were required to make rings, so you could just have like the wall and then the ring part, use 1 or 2 of those, and then embed the washer in the middle with the bolt, and then extend off the size of the head with these pieces. And then I can show a wall, which is just one of these without anything. And so it's like different sizes, and once you get kind of like this ring blank, then you can embed like custom jewels right on it, or add things to the top. It's like a blank canvas of a ring. Here's brass knuckles, same idea. You just need like 3 or 4 of those in between 2 of these plates, and then you can pour it. This one has to be poured from the side, which makes it so that one side looks polished and the other side looks kind of goopy. I changed the design so that there's a pour hole in the top. And it didn't really matter much. Both of them had a flaw. Both of them worked well.
What are if you go back, what are the little waves that are coming from the colors? Like, are those
Those are dilation amplifications of the size or the shape. So they're just kind of aesthetic there. And the algorithm has like a cross and a square mode. So if you're seeing kind of a bias towards like a diamond shape, that's probably like algorithmic artifacts rather than what I was trying to do, which is like as best as I can, just like amplify the shapes. Because all these pictures are completely boring originally. They're just black lines on white background. I went into making, they're not quite cogs, they're kind of like gear for belts, teeth belts. And I make them by making a gear and then doing some kind of like photo or Illustrator pathfinding stuff to cut off like everything outside of a circle. So you can use those just kind of like sawed off gears just for belts. And then you take one of those and you bed it in some of these collars, and then the belt can't derail. These are little tabs, kind of like rings, where you slide it on a tab, and then the other one is parallel to the original. So you take a piece of copper, slide one of these on, and then 90-degree shift one of these other tabs, and then I epoxied the whole thing just to give it a nub so that there's a little tab on the torque forge's buttons. Here's what the sprockets look like before they've been path-founded to just remove all that chattel. And I print these on malleable plastic. These are the belts. Sadly, with malleable plastic, just through use, they're going to elongate. But other materials might suit them better. Here's a close-up on the two chain links that are together, and you notice that they all have little vector numbers so that I know by number what's the next one in the giant stack. I think this one ran up to like 140 pieces. Usually once I've printed about 120 pieces, I get kind of bored of the project. And here's the long slats for the torque forge. We got registration points, and then all of the holes line up so that every like half inch you have a new sensor on the concentric band.
What was the torque forge?
These are 2 sticks in light board.
Oh,
Yeah. And here's the like hand-drawn, vectorized, almost looks like bones that I went with for the last Meat Machine player piano. And here's what I'm planning to do for kinematics, where I just give students a bunch of pieces, and then they all have holes, like axes, and then also these you stabilize things. So you put like latch 2 of them on, and then you put like a stabilizer cotter pin through these slits. That way, they're just really modular, and they're meant to be heat bent. So you just choose an axis that you want to. So you create like a box out of that one right there. And these ones have like an embedded gutter so that there's a movement possibilities. These ones didn't get corroded right, but these are just close up on all those little 2-piece pins. Here's these little cotter pin ply notch things that you can put them through these holes, and then depending on the width of them, they can handle like 2 or 3 different planes of material. So it's a way to kind of liberate myself from washers and all those metal fasteners and threaded bolts I've been using. Is just print my own fasteners. That way I can get through a metal detector. And this is just like the proto board. Like students would just have like a giant field of notches and axes to make linkage systems on. And here's intermittent gears. You can stack them up so that like on layer 1, a full gear will affect this one, so that this one is only in effect half the time. And then so you can just layer them so that like this one using these 3 holes is stabilized to this one, and then this one interacts with another one. So you can make like a chain reaction multipliers, but usually it's just a matter of like motion breaks down at a slightly idiosyncratic rate, especially if gravity's involved, because gravity will always, whenever there's like a half, then like once it reaches the last tooth, then it's liable just to slide until it hits something again, if gravity is involved. So these ones have 2 holes in the middle. Those 2 holes are sort of concentric instead of 1 hole, and that makes it so that you can make a kind of like you take a plane. So we were using it for horses, and we wanted to have a crank that could affect stuff on the left of the body and the right. So you just have a hole in the middle, and then these guys can take motion to either side. And that's required is like a stabilizer. Like once you have 2 holes, then that's a stable fulcrum. And then the 3 holes is just a standard, an overkill standard I got into. Here's my newest design for a slip ring. You can nest tons of these on top of each other, and then there would be like a blank in between each one, so that pins could push against a concentric piece of copper, and then they would always, these 4 pins would work together. They'd all be, at least 1 or 2 of them would always be in effect at any one time. And so with this, you could, you can put a VGA monitor. Probably easier to do a video cable monitor on a rotating surface, and then just splice the RGB cable apart, and then just stack up the slip ring, and each slip ring takes one of the wires. Sometimes I've worked with big plates, and it's pretty important to have them all be the same pitch, otherwise they're going to mesh and seize. So they're all the same pitch, but just one has like 100 teeth and the other one has 20 teeth. This is just for a lamp I made. This is like the base plate. And this is like a gravity wind chime. Ideally, you'd have like a stick that's down the middle, and then you have like conductives wrestled around these little spindles, and then whenever the thing in the middle vibrates, it's going to hit one of the sides and send electricity, saying, so like it knows that rotation is on that one right there, and then so if you just rotate this thing, then electricity will just move around. Last year's work, these are all these stabilizing heads for bolts, and then you can just spin up and down either a contact pickup or a resonating electric coil. So this is just for micro tuning. So you can get, because resonance and magnetic stuff, they have to be just like to the exact millimeter. And one of the easiest ways to do that is just with a threaded bolt. But then you wind your wire up, so good things, bad things. This is an assembly for a bunch of thread bobbins that have copper, 4 ohms of copper on them, and then 2 guitar pickups. So a lot of time laser cutting is just calibrating your drawings to real-world objects that you want to cannibalize into the art. And there's just this crescent goes on that crescent and embeds a bunch of metal prongs. And just instantly you can get something aesthetic if you just go concentric with designs. You make one shape and then you just scale it with duplication, and auto duplicates scaling down. And I made these to be kind of little player pieces in a board game. And all you need is one design and then scaled versions of it. Here's a fan blade from an early trinket electric toy. Close up on this amazing little method using bolts and washers. Sometimes the laser cutter, it's got a 36-inch bed, and if you wanted to make something that's 50 inches, you just got to probably bolt it in certain places. These are all ribs for pottery. I just laser cut them and then had to take them to a grinder to make them nice and biomorphic, 3D, shave off all their sides. This is for the prosthesis or the angle grinder foot. I had to put another 1 or 2 inches of heel on the boots, and so a bunch of pieces that looked like this had to be the complement of what the angle grinder required. The next one kind of declares that really well. These are the pieces where you can kind of see like the angle grinder and its cord. And there's one point where the angle grinder's cord has to kind of like sneak up, so that if you looked at all the pieces, no piece by itself allowed like a cord to run all the way through. But if you stacked up the pieces, there's kind of like a tunnel that let the cord come out the heel of the foot. Just to save area and for aesthetic reasons, to make these systems lighter, I just put on aesthetic holes in the gears. Hopefully not to compromise integrity. Sometimes I would want to aesthetically carve things to the point where it would damage the integrity, and it's really not worth it. You can see like one of these is a little bit lower than the others, or two are higher than the others or something, but these are just 3 stabilizers to hold up a motor in it. And just hot glue is enough, but one of them is, 2 of them, they're just a little different because the back of a little DC motors inside of printers is a little bit smaller on the back. So you just put these 3 pieces in that, and then you can stabilize a motor at about 3 inches.
Derek, can I ask a question, or you want me to wait till the end?
Oh, questions are fine.
So you use the laser cutter a lot, or primarily to make these flat pieces that you build up into a 3-dimensional space, and then you do welding and ceramics and all these other things that are very 3-dimensional. I'm wondering why like 3D printing is not, to have gears that are around, or to have like, it seems like your imagination could build in that structure and sort of 3D printed, and also I'm just wondering why you haven't done that, or why you.
Oh, it's the wrong industry. 3D printing stuff. I don't know. You're either gonna get your tie stuck in the drill bit and kill yourself, or you're gonna get knickknacks out of the MakerBot that don't ever really appeal to anyone other than like a 3rd grader. I mean, laser cut is a powerful tool for planar work, and I've just been happy to leech and milk off of this digital technology teat. And it's got its limitations. I just practically want to run it as far as I can, and then once I don't have the material again, I probably should kind of reject all the high-priced digital stuff. I wouldn't be found dead at a MakerBot or like one of those make factories where I'm just like one of the patrons of a facility. I mean, I'd rather just get a bunch of rickshaw tools at home and do it without having to pay rent.
And I think if I've heard you right, you're talking about questions of scale too. So as far as scale is concerned, that's something that's operating at a far smaller scale than with this you're talking about making things that are even bigger by bolting things together.
The first year or two, and the first half of the second year of danm, I loved laser cutter and thought that its stuff was great. But then I started realizing that you just leave it out in the backyard and it falls apart, And then my thesis show I just read like, let's get back to what works. Like before the digital cutesy saccharine toys, there's just hard metal, and that's going to work great and does what we're trying to emulate. But just as a prototyping tool, as an intellectual tool, it's almost like philosophy what you can do with like spatial features instantly. And
Is that so? Like you were talking about the kinematics components that you're making. Is it almost? It almost seems like it's a more complicated or a personalized version of the erector set in a way.
Yep.
You've developed this sort of erector set like system that I'm wondering too. Like you're using a lot of acrylic to build those things. Does it need to be acrylic in the sense that you're making tons of these little parts, and like how are the materials that you choose important to the object that you're, or the system that you're making?
I was really big on just fiberboard for a long time, just because it's cheap and it cuts fast. And plexiglass I'm only into lately, just because I got a hoard of it, and I'm kind of impartial. I don't really appreciate it too much as a burnable, because just the smell and the toxicity, it's just death. It's almost like riding a motorcycle. But just like the possibilities of it, like it's sad, but like these are variations on the previous ones, but these are meant to be bent. So you just heat gun those, bring those tabs down to 90 degrees, and then bring these tabs up to 90 degrees, and then this object in itself is like the hardened 3D object that just needs to be assembled.
So these things that you're making, are they, do motors attached to them, or is it all like, it almost
Yep, this is all you need to embed a motor kind of stably in a like a box. So that's the hole for the motor head to go through. Those 2 holes are to bolt the motor to the front, and then these 3 stabilizer like tables just hold it fast.
And are you gonna write, like, you're making almost like a Play-Doh system for your work, or like sort of kind of like teaching tools that you can teach directly to, kind of like in the arena, how you were building all these like things that you can do with it. Do you have this sort of like script of what people do with these objects and that they can break from that mold, or?
Yeah, I'd say that they're definitely presented as a launching point, and wherever they mutate what their kind of generic intentions are is where like the next laser cuts, if I still can during the classes running, you know, what do they need to heighten where they're going to take these sets. So it's a strange idea to offer them the previous work of mine as a research for what they need to know before they take the next step.
What's the premise of the class?
Oh, just machine and motion art, and no motors, no electricity, as fun as that is. Only in hindsight of like what happens with just air, water, wind, and gravity, and torque and rotation. Yeah, all about rotation.
Did you, I'm sure you sounds mentions, but did you see that film or did you use that as reference for The Way Things Go? I think that's called. It's like this hour-long film. These guys set up in a warehouse where it's like a tire rolls and it says something.
Oh yeah, that's a beautiful piece. And then the trash bag starts rotating as like the return to calm, and then it starts all over again. Chess set. All you have to do is scale that horizontally, and then it becomes 3D. I made these for embedding pieces of flat tire into all these knobs to make kind of flappy gears. As soon as the laser cutter starts working, I'm gonna take like 1/2-inch ham and start printing gears directly out of it, because I think that's just like where it needs to go. It only lasts for about an hour, but the sound and like what people will feel when they see a mechanical system made out of flesh, it's gonna change things.
Is it like jerky, dry?
I don't want it to dry.
But you'll need it for the gear, like, right? You'll need some kind of stiffness maybe
Sure.
to keep it from, like, to get the gear from just like breaking off.
Is it functional or?
Oh, it's only functional as thought.
That's not.
But yeah, to hand crank and then for meat to move itself.
Although if there's like a wheel and there's enough force on each one, it would be more like friction than meshing.
Yeah, I mean, I would actually be disappointed as an owner if I couldn't actually crank the meat at the, with the gears put together.
Yeah, it's definitely gonna be put together. I don't really see a purpose for functionless art lately. I mean, maybe screen printing just because it's repetition.
The publicity.
You talk at all about like screen printing and the stuff that you're showing us? There's a lot of the stuff I remember seeing the screen printing stuff that you put up as a sort of repetition. Let's see what with this stuff. Do you ever take the parts from the pieces and then like arrange them like this and replicate this?
Oh yeah, if you print on opaque things, then you can do collage and do photo stencils with collage. For the residency call, I'm gonna have a dump recology request, and all it's about is like finding found objects that have silhouettes, and then just doing like huge screen prints of found objects. Because stuff at the dump is disgusting. It's disgusting. But if you just revert it back to like its silhouette, then people can appreciate it for its shape. Which is kind of weird, because you could take like a rotting ham bone and then just bounce it into its silhouette. These are all cams. Some of them don't work very well, but the whole idea that the rotating fulcrum, using a square as a rotating fulcrum, makes it so that they seize and they move instead of using a circular. But yeah, the shape, if it rotates them, arms that are kind of levitated on the cam will attenuate based on these shapes. And then yeah, just the crank. There it is. Kind of fell off, but these are pretty cool. These are just pin placers, so you can nest like six pins together, so that when you push the whole thing down, then all 6 pins do this to their like complementary pin across. So it's like this is like a 6-pin switch. Physical. And these are just 2 side arms, so that a piece of plexiglass would be embedded between 2 ears that hold it to a table. Here's some belt buckles. Those are printed for like to be a front belt buckle, but these are printed to be kind of like the side clasp that you slide up and down the belt. And these are made to clasp onto bike hubs. Those require like really small, I don't know, it's 440 or smaller machine bolts. And then these are for fans. This is an idea for an air pump. You just embed kind of like a plastic tube around that goes in and then comes back out. And then as this rotates, ideally there's enough room for the flattened tube. And then a vacuum will start so that it'll suck water in and move it around. I don't know if it's complete yet. I mean, all I would really do is 2 tubes in, left and then back out. But the tolerance has got to be just right, depending on what type of tube. This is a cool idea where you print that first, and then you take those 2 pieces out, and then you turn them sideways, and then you print this, and you end up getting these rectangles that have a hole this way and a hole this way. So it's all about taking out of a laser cutter and then flipping the dimension. That way you can get 3D stuff out of our 2D machine. Hardly even know what this is for anymore. But obviously those 2 pins go in there. Oh yeah, this is for like a sanatorium machine that we made. It was like an oil derrick that kind of like squashed an orifice. I'm sure Andrew would be in the scene that video. It's pretty disgusting.
We discussed that last year, right? The opening exposure?
Yep.
Yeah.
This is pretty cool one. This is for a bunch of concentric pins. The pins over here had to be like 3 layers, and the pins on this side had to be like angled left, and the pins on here had to be angled right. That way when the whole thing spins, then the ones on like the left of the fulcrum get the exact same angle as the ones on the right of the fulcrum. And then if you accidentally spin the machine backwards, then it just destroys itself. But yeah, before I started studying more about slip rings, this method with concentric copper plates was my favorite, even though it had that limitation. One-way travel. Yeah, so there's just lots of different ways to make walls. These curved swords are just fan blades. There's a lot of jigsaw kind of nesting that can be done to get 3D stuff. So this was meant to be kind of like a mesa, and then these are kind of like the walls that are at a 45-degree angle. I really want to print out a bunch of these because inside of every keyboard there's a little pinout on its like little egg white dongle, and all you have to do is just put copper through all these holes, and if you have the right one, then you just press it against the inside of the keyboard. Throw away the keyboard and just use the pin terminal for the shift register, and then you just have like a copper wire that is all the different pins for this keyboard instead of like the synthetic polymer mesh that they're always using these days with little carbon traces, which you can't solder to. But this way you can solder to any keyboard and turn any junk keyboard you got for free that's USB into a, like a 20 pin digital in. And a 2-pin digital out, just so you know, because there's 2 LEDs on keyboards. This is some stuff to make geodesic domes. There's lots of different ways you make geodesic domes, but if you make like a frequency 3 geodesic dome that has 3 different lengths, you actually in actuality are using 5 different types of triangles, which is kind of weird. So you can make triangles, or you can make the sides of triangles. But yeah, I just worked out the math and the sizes. And you only need like 1 of like this one, and like 5 of these 2, and then 15 of that one, and 25 of that one to make a sphere. Here's some opossum teeth. that were heat bent to wrap around the dentures. Here's a Sierpinski triangle. I think the next picture is a lot better. So some of my best work is just taking a Max program and then just writing an auto header program that just takes polygons and then converts them into SVG files, and then they're readable into vectors, or readable into laser cuttables. And the only trick on that is you just say any polygon, you just give it a little header that says how many XY coordinates are in it, and then just format it right with the right amounts of commas and stuff. You know, all that formatting stuff, and you can turn any drawing that you ever put onto your computer screen into a vector graphic.
Okay, and two things I just remembered, if I can. You send me thesis on, so thank you for that. I'm still, I want to, like.
Oh, don't even read it. I got a better copy.
Okay. Well, I'm digging it, what I have very much, so I can't wait to see what you're okay with. And then, second, to think that, and I understand from word of mouth that at one point when I was away, you did a self-patching max patch.
Called masturbation.
Do you have a copy of that?
Yeah.
Share real quick, or if that would be okay? I got completely fascinated with Max when I was working on my project, and then when I heard that you had a self-patching max patch. You reminded me of it when you mentioned the one that you were just discussing with the polygons, because while not like self-patching, it sounds like that's again got this like the kind of generative aspect behind it, where you're basically giving it a set of instructions rather than you're giving it a kind of meta set of instructions rather than a set of instructions just based on range of objects and the inputs and outputs of those objects. Instead, you're saying, like, I mean,
Yeah, it opens up a new territory of like permutational space if the program is allowed to reprogram itself.
Right.
I don't know. It's like if you're writing just code and you said that the program could just program itself, you might just be saying that like it can integrate and change all of its archives. But in Max, just because it's a spatial language, it's almost like it's a spawning ground, like a spatial spawning ground for logic. So this is what it looks like. There's probably a button to start it. It was originally made for the PC 1600.
So you've got a lot of delays and will we see the patch cables being formed or like connected?
It'd be nice to.
I'm just curious.
Just gotta hit the magic button, just search for the
Yeah,
Well, I know what it is. I know.
I think I'm still in
Very much.
slideshow mode, so it's like disabling my
Yeah.
ability to say
Searching
hi.
for the magic button is something else I spent a lot of time doing on mine, which had a magic button too, and it was like the on switch. If you just, well, yeah, that's what I'm talking about today, actually.
But I could definitely send it to you once I get it up and running again.
Yeah, it's just brilliant. So then there are color changes and other shifts.
Well, the idea was that the like bangs are just allowed to flow down, and that as these guys go back and forth like an old popcorn video game, then depending on the variables, like they're only allowed to like clot or connect to things that are so close to it. So you change those amplitude ranges about how far away it's allowed to expand its impulses. You turn it down and it can only hit the one that's exactly below it. Turn it up and it can hit everything. So one bang gets multiplied out and then it's only allowed to travel. And so it's just like a pachinko game where it makes its way to the bottom. And at the bottom, each one of these final buzzers uses an ADSR to like a different frequency sine wave. And so you get a little song based on like one bang's Frogger game across the max patch.
Fantastic. Thank you very much for showing me that.
Yeah, you'll see it again.
I have a question about like how you get the streets. Okay, so I have put a bit of downstairs. I don't know how much time for each artist, but I don't have to set enough time for that. Okay. I just want to ask a question. What about all those drawings? Do you do anything with the drawings and that you're presenting? How have you put anything out, or do you see it working with the object? And you put so much energy into colorizing everything. They're beautiful.
Well, ideally for this presentation, like what I wanted to do is have like an iPad, and then each one of those drawings was kind of like in the iPad, and then maybe they just like float around, and then like I can touch one and then bring it to the center, and they're all transparent so that they overlap with each other, and then I could just bring one to the center and throw it away, bring one to the center, throw it away. So I wanted to make a little interactive video game presentation of it, and yeah, every once in a while something's good enough that just as a piece of graphic visual design that it deserves like a screen print or an edition. Yeah, I've done a couple of screen prints this last year or two that were based on Max programs, just make like a ultra complicated fractal pattern and then just tone it down just right for a screen print.
I mean, it's an interesting, when we were talking about, having things that can be sold, and that, I mean, to have an edition of that in this point that we're doing is kind of interesting. It's an interesting way to generate drawings. Do you know, John, have you ever looked at Joshua Davis's paintings, programs that he does? Josh Davis? He might be, I mean, they're kind of different things. I think it's just programs that generate paintings.
Oh, yeah. It's colors.
Yeah, yeah.
I'll have to look them up.